Here we have a cyclohexadiene structure, and we have seen how the reaction works with cyclopentadiene. So the same approach could be applied to cyclohexadiene as well, except you have one extra carbon. And here this is the diene, and here is the dienophile. And the diene here is symmetric, therefore the product is going to have only one regioselectivity. And the dienophile is an alkyne here, which is different from typically the alkenes that you would have seen in other problems. That being said, let's go ahead and number it. So 1, 2, 3, 4, 5, 6, and let's call this A and B, and therefore the product is also going to have a cyclohexene with the 4 carbons on the diene and the 2 carbons in the dienophile. So 1, 2, 3, 4, and for 5 and 6 we can draw it like that, nothing wrong. So this is going to be your 5 and 6 carbons, and you have the double bond over there like that. And A and B are going to be your alkyne, and if you want to draw arrows to show how the bonds are made, then the dienophile is going to make a bond with carbon 4. These electrons move here, these electrons move from carbon 1 to carbon A. And since you have an alkyne here, you are going to have a double bond on the product structure, and therefore there is no possibility of an endo or an exo, since this is going to be an alkene. Therefore on one carbon you're going to have a hydrogen, and on the other carbon you're going to have your ester group OCH3. So even though this is a bicyclic structure, there is no endo or exo because it's now an sp2 carbon. And if you still want to show this in a good 3-dimensional notation, then you can draw it like that. Now this structure, as you can see, the product is in transoid conformation. So you had to first draw this in cisoid conformation by rotating that bond over there. So that's your cisoid conformation for the diene. And as you can see here, the diene has trans geometry on the methyl groups. So it strands on this C2 C3 carbon, it strands on this C4 C5 carbon as well. So 1, 2, 3, 4, 5, 6, and here in the dienophile you have cis cyano, C triple bond N. Let's call this A and B now. Okay, so it is simply going to be a cyclohexene structure, and you have trans. So since it strands to the carbon C2 C3 here, right, so this carbon carbon bond and this carbon carbon bond, they should be trans, and similarly this carbon carbon bond here and this carbon carbon bond, they should be in transoid geometry. So 1, 2, 3, 4, 5, 6, and in the product structure A and B, and since the cyano here are cis to each other, here also they are going to be cis to each other. They're going to be on the same side of the plane if you show them, where the hydrogens are going to be on the same side as well. That is the product structure.